Hello everybody and welcome back. Root Beer here with question number 16 on the 2004 grade 7 Gauss. So question 16, what is the maximum number of rectangular wooden blocks with dimensions 20 centimeters by 30 centimeters by 40 centimeters that could fit into a rectangular box with inner dimensions 40 centimeters by 60 centimeters by 80 centimeters? Okay. So, when I look at this question, I am noticing that, 20 times 2 is 40, 30 times 2 is 60, and 40 times 2 is 80. And so, if you know about these sorts of things, if you can realize that these tinier blocks are being scaled up by 2 on every side, you can realize there's a connection between doubling all the lengths, and that translates into multiplying the volume by 8. It also, if you double length, it multiplies area by 4. And it's not just doubling. If you triple things, you can expect area to go up by 9 times, and volume to go up by 27 times. So basically, if you increase every length of something by a factor of r, the area will increase by an r squared factor, volume by an r to the 3 factor, r cubed factor. Okay, so that's the connection I would make, and I'd realize, the 8 times the big box is 8 times the volume of these smaller boxes, so I should be able to fit 8 of them in there. But that's sort of more an advanced connection that you can make. If you were doing this question and you didn't know anything about doubling lengths, well, now you do. But if you didn't, this is how I would approach it. I would calculate the volume of these smaller wooden blocks, and I would then calculate the volume of the big block and divide them and see what number I get. Now, that doesn't guarantee that the blocks will fit, because maybe the 20 by 30 by 40 are a really weird shape, and maybe none of them will fit. I mean, if there was a by 90 in there, no way it would fit into the big box. But then we could start to think, well, how could I fit 8 of these in here? Okay, so take volume of the block, and that's 20 by 30 by 40, so it's going to be 3 zeros at the end. 2 times 3 is 6, times 4, 24. So it'd be 24 centimeters cubed if you want to keep your units there. How about the volume of the box? Well, that's 40 by 60 by 80. Again, we're going to get 3 zeros here at the end. 6 times 4 is 24. So actually, I could even just write 8 times 24,000. I don't need to finish this off. We could. I'll grab my calculator for that, just because it's handy. 8 times 24. So it'd be 192,000. Okay. But this 8 here is kind of critical. Box is 8 times the size of blocks. Okay, so if the blocks weren't made of something solid, because solid things can't be manipulated, they're not malleable. If it was made of liquid, if we were pouring 24,000 centimeters cubed of liquid into this box, we'd be able to get sort of 8 pitchers full. But they're blocks, so we have to stop and think, can we actually fit all these blocks in here? No, starting again, I can do that much better. So I'm going to draw my giant box and see if I can divide it in such a way that I could fit 8 blocks in there. Okay, so we'll use the blue. If I actually cut these sides in half, I will get identical blocks. So the sides of the big thing are 40, 60, and I guess this one should be 40 should be the small one, shouldn't it? So I'll have 40, 60, and 80. And if we've divided the 60 side in half, we get 30s, and then we get 40s, and 20s. And so you can see, especially right here, these are going to all be blocks of 20 by 30 by 40. So we can fit 8 blocks in the box, and that is what? Answer D. Okay. So we fill in D, and we're going to flip our page in anticipation of our next question, and that'll be question number 17. So thank you guys for watching, and I'll see you next time.